Welcome to the deep dive. If you're tracking this huge intersection between climate policy and what's happening in our oceans, this deep dive is definitely for you.
Yeah, it's a critical moment.
We're looking at how we manage the science behind making sure offshore wind development doesn't, well, undermine our fisheries and coastal ecosystems.
And our main source today is a really important paper from 2023. It's titled Science Priorities for Offshore Wind and Fisheries Research in the Northeast US Continental Shelf Ecosystem.
Right.
The lead author is Elizabeth T. Methratta, and it's co-authored by her colleagues at NOAA fisheries scientists and managers who are, right there on the front lines of this.
So this isn't just theory. These are the people dealing with the reality. What was their sort of mission with this paper?
It's intensely practical. They wanted to nail down the absolute must-have research needed to ensure that this pretty much, it's like a high-stakes risk assessment. You look at the federal goals, 30 gigawatts of offshore wind by 2030, aiming for 110 gigawatts by 2050.
Wow.
It's less a gradual shift and more like, boom, industrializing large parts of the ocean to be climate targets.
Exactly. Turning policy into huge physical structures out there.
Sure.
And the Northeast U.S. Continental Shelf, 260,000 square kilometers? That's the starting point.
That's the vanguard, yeah. Right now, you've got over 25 projects proposed just by 2030. That covers, let me check the number. Yeah, over 930,000 hectares, almost 1 million hectares of ocean floor.
A massive footprint.
And that's the core conflict, right?
Yeah.
This development fundamentally changes the marine environment, the seabed, the water column acoustics, the currents, everything. And it impacts fisheries.
So we need the science to understand how to avoid the worst impacts, or minimize them, or mitigate them if they can't be avoided.
Exactly. Mitigation is crucial. If the science doesn't keep pace with the development timeline, we're kind of flying blind.
Okay, so how do they tackle this? Taking such a massive challenge and making it, manageable. Sounds like it could be overwhelming.
It really could be.
Mm-hmm.
But they did a very systematic job. They didn't just brainstorm. They built on existing work. They gathered research needs from 17 different documents already out there. Federal reports, state plans, NGO studies, you name it.
Okay, compiling everything that people had already identified as a need.
Right. And that initial list was huge.
Oh, huge.
533 individual research needs.
533. Okay, yeah, that's information overload.
Definitely. So the real value they added was in synthesis. They took that massive list and distilled it based on things like urgency, importance, and critically, whether the research could actually reduce the uncertainty we face.
And they got it down to
33 priority research areas. A much more focused list.
That's a serious distillation. And they grouped these 33 priorities into 5 main themes for NOAA fisheries science.
That's right, 5 themes to organize the priorities.
Okay, what are they? The first one sounds a bit bureaucratic. Support regulatory processes. Why start there?
Well, it makes sense if you think about it. That science has to be usable, right?
Yep.
Immediately. So theme 1 is supporting those regulatory processes. Theme 2 is mitigating impacts specifically to NOAA's own scientific surveys.
Okay.
Theme 3 is advancing the core science, understanding interactions with ecosystems, trust resources, fishing communities. Theme 4 focuses on the science of mitigation itself when impacts are unavoidable.
He's on the last one.
Theme 5 is data management. Hugely important but often overlooked. Starting with regulatory needs just ensures the science feeds directly into the decisions being made now by agencies like BOEM.
Got it. Okay, let's dig into theme 1 then. The human dimensions, the socioeconomic side. When people think about wind farms and fishing, they usually picture like a closed box on a map. But the paper says it's more complex, these de facto exclusions. Can you unpack that?
Yeah, de facto, meaning in practice, even if not by law. It means fishermen might not be officially banned from an area, but they effectively can't fish there safely or economically once the turbines are up and running.
So practical exclusion, not legal exclusion. What causes that?
Several things they point out. A really big one is insurance.
Insurance.
Yeah. Apparently, insurers are often unwilling to cover large commercial fishing vessels operating inside the turbine arrays because the risk of collision is just too high or perceived as too high.
So if you can't get insured, you can't risk going in. Simple as that.
Exactly. You're not legally barred, but you're practically excluded by your insurance policy. That's a de facto exclusion.
That really shifts the focus. It's not just about planning boundaries, it's about financial risk.
Precisely.
Mm-hmm.
And there are other factors, too. Just maneuvering a large vessel, especially with certain gear types like trawls, can be really difficult or dangerous between turbines spaced closely together. Then you have things like subsea cables needing protection, potential radio interference affecting navigation systems. It all adds up to make fishing in those areas either unsafe or just not economically worth it.
Okay, so if these exclusions are driven by things like insurance or how boats move, why is scientific research the priority? Sounds more like a policy or engineering problem.
Because the science needs to measure the consequences of those exclusions. You need research to quantify the economic costs, like how much extra fuel do boats burn going around? What's the cost of developing or changing gear? What's the actual value of the fishing time lost?
Measuring the dollars and cents?
Yes, but also the non-material impacts. This is really important.
The social and cultural side.
Absolutely. The paper explicitly calls for research on the effects on fishermen's well-being, their mental health, the impacts on cultural identity, fishing heritage, and these coastal communities where fishing isn't just a job, it's, who they are.
That's a much deeper level of impact.
And they also specifically flag the need for research into environmental justice, making sure that underserved communities aren't disproportionately harmed or displaced by these developments.
Okay, that really paints a picture of how OWD ripples through the entire coastal community fabric. Let's shift focus now, go beneath the surface. The impacts on people are often driven by what happens to the marine life and the ecosystem itself. Theme 3 covers these ecological unknowns, and the paper hammers home the need for baseline data.
Yeah, this is fundamental. They state very clearly that you need a minimum of 3 years of solid, robust baseline data collection before any construction starts.
3 years minimum. Why is that time frame so critical?
Think about it. You need to understand the natural ups and downs of the ecosystem before you introduce a massive change like a wind farm. Marine ecosystems have cycles, seasonal changes, year-to-year variations in fish stocks, temperature fluctuations, currents.
Right, things are always changing anyway.
Exactly. Without at least 3 years of data, you can't confidently tell if a change you observe after construction is due to the wind farm, or if it's just part of that natural variability, or maybe broader climate change effects. It's about separating the signal from the noise.
Okay, makes sense. So, assuming we get that crucial baseline data, what are the top priority impact-producing factors, the IPFs, they say we need to study long-term?
Well, they highlight several key ones. First, energy emissions, starting with noise.
Noise is a big one.
Huge.
Yeah.
You have the intense noise from construction, especially pile driving for foundations. But then there's also the lower-level chronic operational noise from the turbine spinning year after year. They say we need long studies, like 5 to 10 years, to see how this noise affects species. Does it displace them? Does it cause physiological stress? How does it impact different life stages, like larvae versus adults?
And noise is just one type of energy emission they mentioned.
The other is electromagnetic fields, EMS. This is the invisible one. We really need to understand how the magnetic fields from all those buried power cables, the ones connecting turbines and exporting power to shore, affect species that are sensitive to EMFs. Think sharks, skates, rays, maybe even lobsters and crabs.
How could it affect them?
Well, many of these species use the Earth's natural magnetic fields for navigation or detecting prey. So how does introducing these strong artificial EMFs mess with their behavior, their movement, their migration routes? We don't really know yet.
Yeah, that's a concerning unknown. Okay, beyond energy emissions, what about physical changes?
That falls under habitat change, specifically the creation of artificial reefs.
Ah, the structures themselves.
Right. The turbine foundations, the scour protection around them, the cable protection, they all introduce hard structures into areas that might have been soft sand or mud before. So how does this change things? Does it increase the density of certain fish? Does it change the mix of species? Does it alter their diets?
And does it potentially bring in unwanted guests?
That's a key concern, whether these new structures act as stepping stones for invasive, non-native species to spread.
Okay, and the fourth big factor sounds pretty worrying. Contaminants.
Yes. This involves potential leaching from the structures themselves. Think about anti-corrosion coatings or sacrificial anodes used to protect the metal materials containing things like zinc, aluminum, maybe even plastics or compounds like bisphenol A.
Leaching into the water over time.
Into the water and potentially accumulating in sediments over the decades, these things will be out there. The critical question, especially for fisheries, is do these contaminants build up in shellfish or finfish living nearby to levels that could exceed seafood safety standards? That needs careful monitoring.
Definitely. And these concerns, habitat change, potential contamination, they feed right into another major issue covered in Theme 2. The impact on scientific surveys. You called it a potential survey crisis.
It really is a major challenge for fisheries science. The issue is that many planned OWD lease areas directly overlap with the established routes and stations used by critical NOAA fisheries scientific surveys.
How many surveys are we talking about?
The paper identifies 14 different surveys potentially impacted in the Northeast, and some of these are incredibly important long-running data sets. Like the Northeast Fisheries Science Center's Bottom Trawl Survey, it's been running consistently since 1963.
Wow, 60 years of data.
Exactly. That data forms the absolute backbone for assessing fish stock health and providing the scientific advice needed for setting fishing quotas and managing the ecosystem.
So if the survey vessels can't safely tow their gear through a wind farm area, or if doing so messes up the statistical design.
Then you break that crucial time series. You lose the ability to compare year-to-year changes reliably. The data becomes less certain, potentially unusable for management. That directly impacts our ability to manage fisheries sustainably.
Which leads straight into theme 4, the science of mitigation. If you can't survey the old way, you need new ways.
Precisely. Since the OWD is happening, we urgently need to develop, test, and validate alternative survey methods.
What kind of alternatives are they looking at?
Things like advanced acoustics, passive listening, or active sonar to detect fish, environmental DNA or eDNA, sampling water to see what species are present, using uncrewed systems like autonomous underwater vehicles or surface drones, applying AI and machine learning to analyze imagery or acoustic data.
So lots of high-tech approaches.
Yes, but the key challenge isn't just using new tech. It's rigorously proving that these new methods can provide data that is just as accurate and precise as the traditional surveys, so we can maintain the integrity of those vital long-term data sets. That comparability is absolutely essential.
And mitigation under theme 4 also loops back to the human side, right? Compensating fishermen.
Yes. Another key priority is developing robust, agreed-upon methods for assessing the economic losses to fishing communities when impacts just can't be avoided or minimized through planning. This is vital for designing fair, compensatory mitigation programs.
Okay, we've talked about individual impacts, noise, EMF, habitat, surveys, economics. But the paper points out the really big challenge is how these all add up. Theme 1 again. But looking at cumulative effects, how do you even begin to assess that level of complexity?
That's the million-dollar question, maybe billion-dollar question. Assessing the combined synergistic effects of multiple wind farms, interacting with climate change, interacting with fishing pressure, it's incredibly difficult. The uncertainty is very high.
So what's the proposed approach?
The paper recommends moving towards more holistic frameworks, specifically things like integrated ecosystem assessments, IEAs, and applying principles of ecosystem-based management, or EBM.
What do those frameworks actually do?
They provide tools and processes to look at the whole system, not just one piece at a time. They help evaluate the trade-offs between different ocean uses, like energy production versus fishing versus conservation. The goal is to integrate OWD impacts into the broader context of managing the entire marine ecosystem.
So a way for decision makers to weigh the pros and cons across different sectors.
Exactly.
Yeah.
Underpinning all of this complex science, whether it's baseline monitoring, impact studies, or ecosystem assessments, is Theme 5, data management.
Ah, yes, the crucial plumbing. Sounds potentially boring, but probably essential.
Absolutely essential, and a huge potential bottleneck if not done right.
Huh.
Imagine all the data being collected by different developers, different agencies, different research groups for dozens of projects.
Yeah, chaos.
Right, so the paper stresses the critical need for standardizing how data is collected, formatted, and shared. We need common quality control procedures, metadata standards, and crucially publicly accessible data portals.
So everyone can use the data, and we maximize the value of these incredibly expensive ocean studies.
Precisely. Transparency and accessibility are key.
Okay, so looking at the big picture, these 33 priorities identified by Methratta and her colleagues, they really serve as a critical starting point, a kind of scientifically vetted checklist for what needs to be done.
They absolutely do. They're intended to inform the development of a more formal NOAA fisheries science plan, specifically for OWD on the Northeast Shelf, helping to focus limited research funding and effort where it's needed most.
Important to remember the caveats, though, right?
Yes, definitely. The authors are clear. These priorities reflect the expert judgment of the NOAA scientists involved at that time. They aren't necessarily official, locked-in agency policy yet. And while focused on the Northeast, many of the issues are relevant nationally or even globally.
And making progress on this depends heavily on everyone working together.
Absolutely. None of this happens in a vacuum. It requires really strong collaboration, maybe sometimes challenging collaboration, between NOAA, BOM, the agency that leases the areas, the fishing industry through groups like ROTA, the wind developers themselves, and the academic research community.
It's a huge collaborative lift, but also an opportunity for innovation.
A massive opportunity. The paper touches on this, the need to apply novel scientific approaches, things like sophisticated before-after control impact study designs, or the before-after gradient design they mentioned, integrating all this new technology, AI, robotics, advanced sensors, to actually gather the data we need at the scale required.
It feels like the scientific planning is finally starting to match the scale of the OWD ambition.
The ambition is definitely there, and maybe here's a final thought to leave people with, something that really struck me in the paper's implications.
Okay.
Many of these critical research questions, it's especially around long-term ecosystem changes, cumulative effects, maybe contaminant buildup, they don't get answered in a year or two. They require monitoring for decades.
Hmm.
We're potentially talking 30 years or more, the entire operational lifespan of these wind projects, right through decommissioning.
30 years.
Yeah. This isn't just a research project. It's essentially a multi-generational scientific commitment we're embarking on right now as this massive build-out begins. It's a huge undertaking starting today.
A multi-generational commitment to understanding our impact. That definitely puts it in perspective. Thank you for guiding us through these really critical scientific priorities.
My pleasure. It's vital work.
Thank you for tuning in to this deep dive into the science needed for offshore wind and fisheries to coexist.